right. So everything so far has been based off of right triangles. The law of sides is when we have triangles that are not right triangles. So if you want to find missing sides, missing angles of a triangle that is not a right triangle. It doesn't matter what kind of triangle it is. It could be acute, obtuse, any equilaterals, right? Although you don't really need law of sides to do that, but you could. It will help you find sides and angles of non-right triangles, all right? And here's what the law of sines says. You have a triangle that is not a right triangle. It has angles A, B, and C. We're going to be super creative. A, B, and C. Across from angle A is side A. And so it's capital A for the angle, little a for the side. Across from angle B is side B, so little b. And across from angle C is side C, so little c. So you have some triangle set up like this. And there's a relationship between these angles and sides. And so the law of sines says that the sine of angle A divided by the side of A, that ratio is the same as the sine of angle B divided by the side B. So the sine of A over its opposite side is the same as the sine of B over its opposite side. And those ratios are the same. And it is also true that it's the same as the sine of angle C over side C. It's possible at the very end of a geometry class that it might have got thrown in, depending on what geometry you had and how many snow days there were. But so this is the law of sines. So in order to use the law of sines, you have to have a side and its angle, right? A side and its angle, and you have to have either another angle or another side. So here's the conditions. Do you remember when we talked about like triangle congruency and you had like angle, side angle, and all that fun stuff? So here's the conditions that you have to have in order to use the law of sines. You have to have angle, angle, side. So in this example, angle, angle, side would be angle A, angle B, side A. You have to have a match, okay? You could have angle, side, angle. So angle A, side C, angle B, and that will work angle, side, angle because we know all the angles in a triangle add up to 180. So you could find this one, so you could have a match. So you always have to have a match between an angle and a side in order to use the law of sines.
Oh yeah, can't this be used to, like, I don't remember what he did here, but he used this to like calculate the height of a tree or something?
Yeah, you could do that.
Can you explain that one again?
Yes. So if you have angle, side, angle, so for example, here, I can drop it here.
But we cannot have.
That would be like having A, B, and then this little C, right, in between.
Okay.
And so you have to have a match, and right now we don't have a match between an angle and a side. But because we have two angles, you know the third angle, right? Because all the angles in a triangle add up to 180, so then there is your match. And you're good.
And then side angle works because of.
And then side angle would be like side C, side A, and then angle C. So that would be a side angle.
But we can't have angle side because that makes it first word.
Yeah, angle side is not enough because we won't have a pair and we can't figure out a pair. Yeah. So it has to be one of these three situations, all right, happening. And so we have examples of all three. By the way, this one right here, the side angle, is the most complicated of the bunch. So we have lots of examples about that one. The next thing is you don't really have to worry about these two. You can just do the math that will happen. This one you have to think just a little bit when you use that one, all right? All right, so here's angle side. So the first one. So highly recommend that you draw a triangle to help you out here. You're gonna want to leave some space because we're gonna solve the entire triangle. So please don't like big triangle and leave no space to write. All right, so I always set up my triangles just like this one here. Just make sure it's not a right triangle. So this angle A here is 61 degrees. Angle C is 72 degrees. And then side C has to be across from angle C, so that would be over here at 13. And so here's what we need. If this is A, this one's B, and this one's C, you have to find all the missing sides and all the missing angles, all right? Before we start, we can find the missing angle really easily, yes?
Yes.
Yeah, they all add up to
180.
180. So 180 minus 61 minus 72, that gives us 47. So the measure of angle B is equal to 47. And you do not need to show any work to get to that. That is a pretty straightforward question, yes? All right, and then we have to find little side B and little side A. So side A and side B are what we're looking for. And so we're gonna do one at a time. And it doesn't matter the order that we do them in necessarily. So as long as you have a pair, you're good to go, all right? So we're gonna use the law of sines. So you wanna do A first?
Yeah.
Sure. So what we would say is we would say the sine of the angle 61 over little a is going to be equal to the sine of another angle over its side. And we don't want to use b and little b because we don't know little b, right? We don't want to have two variables. So we're going to use c and little c. So that's equal to the sine of 72 over 13.
Amazing.
And so you can solve for A and it will tell you exactly what side A is then. Everybody hit mode on your calculator real fast and make sure these are angles in degrees. So make sure your calculator is in degrees on that fourth row. If not, you're just going to get wrong answers.
So what I learned is circles are in radians and triangles are degrees.
No, I could have given you degree measure or radian measures for these angles, but if I said angle A was like pi over 3, it'd be pi over like 3.1. That would be kind of silly, wouldn't it?
It just really sucks.
We just say 61 degrees. So.
We're knowledgeable enough now that we'd be able to figure it out.
It is true. We could have said like sine of pi over 6 as opposed to sine of pi over 3 as opposed to like sine of 61.
Yeah.
We could do that because technically 61 degrees could be written as a radian, right?
Yes.
Yeah, so it's just a different conversion. So it's like if you use inches instead of feet. So just standard for these problems, we just like to use degrees. So it's actually kind of helpful.
Yes.
All right, so how do we solve this equation here? How do we solve that guy? Because it's one thing to get the setup, it's another thing to figure out the solution.
Multiply by a.
Yeah, you can multiply by a to get it out of the denominator, right? Another way you can think about this is cross multiply. You have a fraction equal to a fraction. So you can technically multiply across, right? So if you multiply this way, that would be 13 sine of 61 equals a times the sine of 72. And then to finish solving for a, you just have to get rid of the sine of 72, which means you have to divide. Yeah, so we would just divide by the sine of 72. And so if you type this value in over here in your calculator, you will get what angle A is equal to. Now when you do this, just be extra careful, yes?
Yeah.
So if you want to put fraction in alpha y equals to get the fraction, you can do that. And so we would say 13, and then sine of 61, and then on the bottom, sine of 72. and we get this number. Or if you don't want to put the big fraction in, you would say 13 sine of 61, close the parentheses, divided by sine of 72. And you technically don't have to close that last one, you kind of do want, it really doesn't matter. And you would end up with the exact same number. What you can't do is not close the parenthesis on the 61. Look at if I leave it open, I get a different value. You see that? So just be careful with how you type it in to your calculator. So it is 11.95. You can round to 1 decimal point. So what's going to happen if I round to 1 decimal point? The 5 is going to make the 9 round up, so it would technically round to 12. So side A is equal to 12. So I can put that up here. This is 12. All right, and then we have to find little b still, yes? All right, so we're going to set up another ratio, and this time we're going to use angle B, so the sine of 47 over little b equals, and when you set up the next one, you can either use C, because you have it and its side across from it, or you could use A, because you have its angle and the side across from it, right? So you have a pair here and a pair here. So it doesn't matter if you use sine or if you use C or A. Does that make sense? So your pick. I'm going to use C because that's the ones that they gave me. And then I didn't have to do any rounding or anything in the number, so I just like to keep it consistent. Also, if you keep it consistent like that, the same thing would happen here, right? You would cross multiply. And so it would be 13 times the sine of 47 divided by the sine of 72. So if you keep it consistent, you can go back to this one. And then instead of typing it all in again, just change that angle there. Possibly. There we go. You can just change the 61 to a 47, and it'll give you that side also. Or you can type it all in again, up to you. And then what does this number round to? 9.996. We'll round to 10. So that means side B is equal to 10. So we have our triangle. We found all the missing sides and missing angles. What do you think about the law of sines? Yes, no, maybe? Do you want to go back to solving those trig identities with all the half angles and whatnot? This isn't, no, it's not that bad. It kind of lightens up a little bit, yeah, here at the end, which is nice. By the way, if you ever want to check your triangle just in general to make sure that it makes sense, the biggest side should be across from the biggest angle, and the smallest side should be across from the smallest angle. So your biggest angle is 72, and your biggest side is 13, right? So that makes sense, and then your smallest was 47, and so your smallest was 10. And so the biggest side across from the biggest angle, the smallest side across from the smallest angle. And it should work out that way. If not, you made a mistake somewhere. That's like a rule of a triangle. All right, let's check out this guy. So I'm gonna go ahead and draw a triangle. I have A, B, and C. A is 13, B is 143, and I have little a, which is 15, and so that one goes across from big A. And so I need to solve the rest of this triangle. So the easiest thing to do first is to find the missing angle, right? When you have two of them, it's easy to find the third. What do you know about the three angles again? They add up to 180, so you should take 180 and subtract, right, the two that you have. That's not 180, I lied. There we go. So I get 24 for that one. So angle C is 24. and we're gonna have to find little b and little c. Does it matter which one we do first? Not at all, right? You get to pick. So, would you like to do b or c first? B. So that means I need to use the sine of angle b over little b. And then the pair that I have is a and little a, right? So I'm going to say that that's equal to the sine of 13 over 15. And this equation solves just like the last one, yes. Cross multiply, right? And then do your division. So you're going to multiply here, and then divide over. You do not have to write anymore. If you write this, you can go ahead and tell me what b is. If you want to write more on the solve, you can. So this would be 15 times the sine of 143 on the cross multiply. And then it'll be divided by the sine of 13. So rounding to 1 decimal. It doesn't like to pick up the calculator. Rounding to 1 decimal, we end up with 40.1. So little b is equal to 40.1. All right, and then we have to do the same thing for c, little c. So we're going to have the sine of angle c over little c equals, and then I just use the same one that I had before, sine of a over little a. And it will solve the exact same way with the cross multiply. So the nice thing is you can just go back up to this, right? And instead of having 143, this is just going to be 24 in here. On the round, we get 27.1. 27.1. So little c equal to 27.1. And in your triangle, is the biggest side across from the biggest angle?
Yes.
Yeah, and is the smallest side across from the smallest angle? Yeah, so we have some pretty good confidence that we haven't messed this up, right? All right, thoughts on that one with angle, side? Any thoughts so far? All right. We're going to do angle, side, angle. Okay, so draw your triangle again. I pretty much set it up the same way every single time. A, B, C. A is 9. Angle B is 20. And little c is 34. So here is our angle, side, angle happening. All right, first thing, the easiest to find is angle C, right? I like when we have two angles. That last one's like a gimme. So subtracting from 180, we end up with 151.
There's obtuse.
Yeah, this is an obtuse triangle. I'm not so much worried about it in my picture though. Don't ever get too focused on the picture. The picture is just to understand the matching sides and what we're trying to find and stuff. So, all right, we have to find little a, and we have to find little b. Which one would you like to do first? A? All right, so for A, it'll be the sine of angle A, which is just 9, sine of 9, over little a. equals, and then you have to use the pair that you have, so sine of 151 over 34. And so this solves just like the other ones, right? Cross multiply?
Yep.
So it ends up being 34 times the sine of 9. Make sure you close that parenthesis. And then wind up dividing it by the sine of 151. So angle A rounded to 1 decimal point would be what number? 11. So side A is 11. Without doing any math, the side B is between what two numbers? 11 and 34, right? Because this is the smallest angle, and we got 11. This is the biggest angle, and it's 1/3, or it's 34. And so B has to be between them, right? Because that's the middle angle. Is it going to be closer to the 11 or closer to 34? Closer to 11? Let's find out. So we have a sine of angle B over little b equals sine of angle C, because that was our original pairing, over little c. And the nice thing is we can just go back, because this is the exact same equation, the only difference is the 9 is now a 20. So you can go back and change the 9 to a 20. If you need to like insert another digit, do you guys know you can hit second insert right here? And then it'll just let you plop in another one without deleting anything. And that one rounds to 24. So was it closer to 11 or closer to 34? It was actually closer to 34, wasn't it? Kind of interesting. All right. But the biggest side across from the biggest angle, smallest side across from the smallest angle, the other one is in the middle between. All right, last but not least, I'm gonna have you try this one on your own before we get into the more complicated ones, all right? So give this one a go. Give it a shot, see what you come up with. angle B, what'd you come up with? 96? Just subtract from 180, right? For side A, 5. I also had 5, yeah. 5. And then C, what is it? 25? 25? I think I had that as well, yes. How did it go? Did you have any questions? All right. You ready to do this last possibility, these side angles? All right. So I don't know if you remember back to geometry, but the side angle case is one of those where you can't prove congruency with side angle. And so at the very bottom of this page, here's what's happening with the side angle options, all right? So if you are just given side angle and you have a triangle that is not a right triangle, you have some possibilities of things that are happening. So the first thing that could happen if you have a side and an angle. So here's the sides that they're referring to. This is actually like an angle side. Do you see them? Angle side. The first possibility is that this side here is not long enough to reach to make a full triangle. In which case, you cannot make a triangle. So if they give you that situation, there's not a triangle possible, and it just wouldn't happen. All right. The nice thing is with this case, is that if a triangle can't be made, the math will tell you that the triangle cannot be made. Okay. So you don't really have to like memorize these situations. It's either the side is not long enough to extend and you can't make a triangle, and the math will come back as like, hey, that's not a possibility. You can't do that, okay? It is possible to make, with angle side, a right triangle. So it is possible that you could do the math and get a right triangle as one of these options, all right? So that is another option as well. And it's possible that you do the angle side, and you just get a normal triangle like what we saw on the front, and all the math works out really pretty, all right? So for these 3 options, the math is going to tell you what's happening. If it is not a triangle, it will tell you not a triangle, okay? If it's going to be a right triangle, it will come back as one of the angles being a 90-degree angle, all right? If you do this one, all of the math will work out, right? And you'll get all the numbers just like we did on the front. Now, when you get into some of these other unique situations, there is a possibility of having 2 triangles that work. And so you would have an angle, a side, and then this side right here, your other side, could either go either direction. It could go out to meet and make a triangle, or it could be swinging in to meet and make a triangle. And this is the only one that the math will not do for you. Does that make sense? So on any other of these possibilities, you do the math, it will turn out perfectly, okay? You really don't have to pay any attention to them. There is one instance, though, where you would have 2 possible triangles, and those 2 triangles, you would, when you do the math, you would only get one of the 2. You would be missing the second one, okay? And so if this is overwhelming to you, 99% of the time, you just do the math, you're going to get everything you need, all right? But there will be a couple where there was a second possible triangle. And what happens with this is it's when A is less than B, all right? So A is less than B, and angle A is acute. Angle A is less than 90. So we'll point out when these things happen, all right? But what you're really looking for is an acute angle, so the angle they give you is less than 90, and your side that makes the pair, the side opposite, is less than the side that runs along this way, okay? That's when you just have to be super, super careful, because there could be a second triangle floating around there, all right? If the angle they give you is obtuse and you have an angle side, in this case, it's possible to have another instance where you don't have a triangle, and the math will tell you, like, it will literally come back to your calculator and be like, we can't do this, and so you're like, okay, that means it's not a triangle. Or if you have this final situation here, the math would come back as just one triangle, and that would be fine. So really, there's just this one instance of all these possibilities of side angle where you could possibly miss the second triangle, okay? At the end of the day, if you miss the second triangle on every single one of them, it is not that big of a deal. On all the ones where there was a second triangle, if you miss it, it's okay, all right? It will not make or break anything grade-wise, all right? But just know that there is this possibility of having two triangles that could have been made there. All right, so we're actually gonna see, I have 5 examples for us, and we're actually gonna see all of them except for the right triangle because that one's super boring, yeah? Yeah, all right. So, here is the first one. We have angle A, little a, and side C. And so if you draw this triangle out, just the general triangle from the before, right? ABC. You're going to have angle A is 123, 11, and 41. And this is a angle side situation. So anytime you have angle side, the one that makes a swear word, angle side, like the first initials, make a not good word to say out loud, then that's when you're gonna be like, okay, there's a possibility of a second triangle, right? Now, this one will not have a second triangle because the angle that they give you is not acute. It has to be less than 90 immediately. So we know we're good, all right? Automatically we're good. Angle's not less than 90. So we can use the law of cosines just like before and start solving. All right, so we need to find angle B, angle C, and little b. So what of that would you like to find first? And you do have to be careful because you should do this in a specific order. What should we find first? Angle A, or angle B, angle C, or little b? Angle C. Why angle C? Because you have the side that goes with it, right? So you can't find angle B or little b because you're missing the angle and the side. You have to have one of the two pieces in order to figure it out. So A is your pairing, and then C is the one where you have the other side. So you're going to say sine of angle A over the side A is equal to the sine of angle C over side C. And we need to solve for that angle C. So how can I solve this?
Just multiply the fraction of left by 11.
Yeah, so you can move this 11 over here, right? When it comes over, it comes to the numerator. So we have 11 sine of 123 over 41. That's a number, and that equals the sine of C. So what you can do now is you can just type this in your calculator and see what number it's equal to. So 11 sine of 123. Make sure you close that parenthesis before you hit divide by 41. And I get this decimal here. So 0.225, and then there's a bunch of more zeros. 0.225 approximately. There. And then I need angle C. So how do I get in there and get rid of that sine function to get angle C?
Sine inverse.
Sine inverse. Yes, you can get rid of the sine by inversing. So angle C will be equal to the sine inverse of that 0.225. And when you put it in your calculator, remember sine inverse is the sine button right here, the sine button. But you have to hit the blue one to get the inverse. So sine inverse. And then you never want to round this decimal. Remember they give you a decimal here? You don't want to round that decimal. So when you hit sign inverse, you need to put that number in there, because if you round it, your answer might be different than mine by a couple degrees. So you can just hit up in your calculator and it'll go straight to that number and highlight it, and hit enter and it'll drop that number in. So you don't have to retype it or anything, just hit up, enter, and it'll drop it in. And then hit enter there and it tells you that the angle is 13 degrees. So angle C equals 13 degrees. So we can throw that in our triangle. We know that one now. So when you're using the law of sines, you will have to sign inverse as well along the way. All right, questions about finding that angle C? Yes, no, maybe? The nice thing is once you know how to find a missing side, it's always the same process. Once you know how to find a missing angle, it's always the same process, right? All right, what should we find now? Angle B or little b? Angle B, because those angles add up to 180. So I have that angle B equals 44. Is that right? 44. And now that you have angle B, you can go ahead and find side B. So this would be sine of 123 over 41 equals the sine of angle B, so 44 over little b. And that is the equation that we solved on the front, yes? So we do not need a sine inverse to solve this second half here. You can just go ahead and cross multiply, right? So this will be 41 times the sine of 44, close the parentheses, and then divide it by the sine of 123. And rounding to one decimal point for the side, that would be 34, right? Just rounds to a nice 34. So side B is equal to 34. All right, and in our triangle, is the biggest side across from the biggest angle?
Yes.
Yes, and the smallest side across from the smallest angle?
Yep.
Yes, so we have some pretty good confidence that we've done it correctly, yes? All right, if you look at the bottom, this was the very last option. Like of the 6 triangles across the bottom, it was the furthest one to the right. That was the situation that was happening there. But the nice thing is unless we're doing the one with 2 possible triangles, we really don't have to worry about it. It will just automatically tell us what's happening there. All right, so let's check out this one. Measure of angle B. We have side A and side B. So we'll go ahead and draw ourselves a triangle. A, B, and C. 154. 32 and 30. So this is still an angle side situation. It's just turned slightly from, instead of having A, we have B now. All right. What should we find first? Because we need angle C, we need angle A, and we need little c, right? Angle A, because we know the side across from that, right? We know little a. So we'll say the sine of 154 over 30 equals the sine of A over 32. And then we'll solve this just like the last one. So we're going to multiply the 32 over and get this number. And then we'll get rid of the sine by doing sine inverse. So we'll say 32 times the sine of 154, close that parenthesis, divided by 30. And so that's what the sine of A equals, so you have to get rid of the sine. So you're going to sine inverse that decimal. And so angle A is 27.9. Rounding to one decimal, 27.9. So angle A. 27.9. Oh, somebody was working ahead. So how do you find angle C? Because that's the next one we need, right?
Subtract from 180.
Yeah, subtract from 180. So we'll do 180 minus 154 minus 27.9. And here's where the O comes in, because we get negative 1.9, right? Can an angle be negative?
No.
No, not in a triangle, right? Not in a triangle. If we're talking like unit circle, we could set negative angles, but in terms of a triangle, if we're solving this triangle, it's not possible for that angle to be 0 because it has to have some value in the positive to make the angle, right? So this is an example of one of those ones where there is no possible triangle. So we would at this point say not a triangle. So the math has told us that this will not work. So whenever something is not a triangle, the math will come back as it is not a triangle. Something fishy will be happening there, all right? This was the second to last option on the row of 6 at the bottom. The angle was obtuse, it was bigger than 90, and this was an example where it just didn't reach far enough. By the way, biggest side or biggest angle, is that the biggest side? No, that one was, right? And so from the picture, across from the biggest side is not the biggest angle immediately, because this is bigger than this one. So we knew that that had to be bigger than 154, but you can't have two angles that are both obtuse in a triangle. It just doesn't work that way. All right, how are we doing so far? Any questions? All right, we're gonna press on. We are down to angle A being acute. It says 3 possibilities. Technically, there are 4 because you could have the right triangle, but that's super boring. Nobody wants to talk about that anyways, right? Right triangles, we talk about that all the time, that's true. All right, so let's draw a picture of what is happening here. So here's my triangle A, B, and C. So we have 87, 16, and 14. All right, is this possibly one with 2 triangles at the end? So, is the angle they give us acute? Yes. And then the next possibility, if you look back to this, right, the angle has to be acute, and then A has to be less than B. So the side across from the angle has to be less than the other side in between. So is the side across smaller than this one? So go back to here. Is the side across smaller than the other side they give you? Yeah, so this would have 2 triangles. There is one other case, though, where that could happen. It could be this one here. All right, and that would give us none. So if we do the work here and we get actual answers at the end, that means there's 2 triangles here. But if we do the work and we get not a triangle, we get something error, then we're done and we're good, all right? But this is impossible having 2 triangles at the end. So let's check. All right, what do we want to find first? Angle C. So we would say sine of 87 over 14 equals sine of C over 16. And solving for the missing angle is the same as solving for the previous missing angles, right? So in your calculator, you can multiply this over here. So we would say 16 sine of 87, make sure you close that parenthesis, divided by 14. And then to find the actual angle, you have to sine inverse this number. When that happens, I get an error in the domain. By the way, remember the sign graph? What was the very top of the sign graph? 1, right? The sign graph, do you remember the sign graph? Goes from 1 down to -1 and up and down between 1 and -1. So is it possible for the sign to be bigger than 1? No, so if you try to sign inverse a number bigger than 1, it does not exist. So is this a 2-solution triangle or is this not a solution triangle? Not a solution triangle. So right here from the get-go, you can say not a triangle. So the nice thing is if it's not a triangle, the math will literally say it is not a triangle. So what is happening here is this side, this 14, is too short to reach. So it's getting stuck. It's actually stopping like there, and it doesn't have enough length to get all the way to that other number. Does that kind of make sense? It's a little too short, unfortunately. So it's just kind of like hanging there and not making the actual triangle. All right, let's try the next one. So let's draw ourselves a triangle. We have angle A, B, and C. 89. Little a is 8, and B is 16. All right, so we have to check because we have side angle, right? Angle, side, and our angle is acute. So this is a possible, we have to kind of look into it. So going back to the option, whatever angle you have is the side across from it smaller than the other side. So the angle that you have, the side across from it, smaller than this one. So back to our triangle, the angle that we have is this side smaller than this one? No, so this is just a 1-solution triangle. Just one option here. So we're going to go ahead and solve, and we know there's just one possibility. So angle A first, right? So sine of 89 over 16 would equal sine of angle A over 8. And so once again, this solves just like all the others, finding missing angles. So multiply the 8 up. So it would be 8 sine of 89. Make sure you close the parentheses and then divide. And since that number is between 1 and -1, I know I can actually keep going here, right? It's not going to give me an error. So I have to sine inverse that number. And it tells me that angle A is going to be equal to 30. Yeah. Angle A is 30. Put that in there. If angle A is 30, what's angle C?
Six.
61.
61? Just subtract from 180, right? So angle C has to be 61. And so far, all of our numbers make sense based off our triangle, right? So then we have to find side little c. So we're going to say sine of 89 over 16 would be the sine of angle C over little c. And that solves just like they were solving on the front, yes? You're going to multiply. We don't need a sine inverse on this one. So we'll multiply 16 by the sine of 61. And then divide by the sine of 89. So I have that side C is equal to 14. So going back to your triangle is your biggest side across from your biggest angle. your smallest side across from your smallest angle? Yes. And all the numbers worked, so we are good. There's just one possibility here. All right, any questions so far? Any guesses what's gonna happen on the last one? Yeah, we're gonna have two. So, let's go ahead and draw it, and we'll make sure that we know why we're gonna have two. So once again, this is an angle side situation, right? Angle side. So we just have to check. The angle that we have, is it acute? Is it less than 90?
Yeah.
Yes. And so now we have to check the sides of things. The sides to see if it's possible. So once again, if you go back to the option for 2, the side that is across from the angle that we have has to be smaller than the other side. So the side across from the angle that we have is in fact smaller. And so since it's smaller, what's going to happen here is either there's going to be no triangles or there's going to be 2 triangles. If there's no triangles, the math will say no triangles, right? We'll get something that doesn't make any sense. And so as long as we don't get something that doesn't make any sense, there will be 2. All right, so let's go ahead and give it a shot. What would you like to find first, or what do we need to find first? We have to find angle A first. So we're going to say the sine of B over side B equals the sine of A over side A. And that will tell us angle A. This will be what, 33 times the sine of 59, close the parentheses, divided by 32. In my head, because that's a 56, isn't it?
Oh.
My bad. I just make up extra numbers, you know. It's okay. 56. Thank you for catching it now and not later. Let me change this. Everything else is good, right? Yeah. Okay, so 33 times the sine of 56. And then make sure you close that parentheses divided by 32. So I have this number, this 0.85. And then you have the sine inverse to find the actual angle. So angle A, I get 58.8. 58.8 on the rounding. All right, so we're still good, right? That's a possible angle measure. So let's check the next step. If I know angle A is 58.8, how do I find angle C? Subtract from 180. So 180 minus 56 minus 58.8 means that angle C is 65.2. So we're still good, right? 65.2. And so let's get side C and finish this triangle. And as long as side C comes out right, then we know that there has to be another triangle here, yes? So for side C, we'll say sine of 56 over 32 equals the angle we just found, sine of 65.2 over side C. So you'll cross multiply, right? 32 times this one, C times that one, so you'll have to divide that over. Sign up with 35. Everybody else get 35 on that? So side C 35. So since the first triangle, everything worked out, all of the angles, all the sides, everything's in there and makes sense, right? We didn't get any errors along the way. That means that there is a second triangle, all right? So if I know there's a second triangle, I like to just like draw this little squiggly line saying, hey, by the way, this is all one triangle. I'm gonna go now and find the second triangle. And here's how we do it. When we found angle A for 58.8, the other option is that angle A, instead of being an acute angle, could have been an obtuse angle. And so what you do is you take the angle that you found, the 58.8, and you subtract it from 180. So you just simply do this. So this was angle A that we found. So 180 minus the angle that we found would give us an obtuse angle. And I just typed in the sine of both of those angles. The sine of 58.8 and the sine of 121.2, and look at what I got. I got the exact same values. That's why there's a second triangle. One of them essentially is the Q1 version, right? And one's the Q2 version. But because they're sine, they're both the same value in Q1 and Q2. So this is the one that our calculator gives us because of sine inverse being restricted. Remember we talked about that on the inverse day, we restricted sine. And so because sine's restricted, it gives us this one. But technically, this 121.2 has the same value and could still be a triangle. So if it is a triangle, and you know there's a second one, just take that first angle that you found, subtract it from 180, and that is angle A for your new triangle. And so what you're going to do is you're literally going to take it from here and do the exact same things. Find C and then find side C, all based off of this new angle. So to find the new angle C, you're going to use 180 minus the angle that we had, which was 56, minus the 121.2. And so for angle C, I get 2.8, which is a valid angle measurement, right? So I just subtracted the original angle from the question and then the other angle, the other possibility for A. And so that's the other possibility for angle C. And then last but not least, do the little c calculation again. But this time, instead of using this angle C, we're going to use that angle C. And so then you can recalculate little c. I ended up with 1.9. So here's the two possible triangles. It's possible that there is an acute triangle and that there is an obtuse triangle. So it's possible that angle A was acute or that angle A was obtuse. But like I said, how many examples? We did 9 today. We did 9 of them, and only one of them was a 2 triangle option, right? The nice thing is for every other triangle out there, if it's a triangle or a mixed one triangle, you'll get all the information just like you should, right? You really don't even have to think about it. But when you have the 2 triangle option, you have to think about it, all right? And so the 2 triangle option happens when you have angle side side and the angle's obtuse, the angle's acute, right? And then the side across from that acute angle is smaller than the other angle or the other side that they give you, all right? That is the only time the two triangle situation will happen, all right? If that two triangle situation stresses you out though, at the end of the day, you will be just fine. Still finding just the one, all right? Just know you'll miss a little bit of points or whatever because you missed the second one. But at the end of the day, do not freak out because of the second triangle. It's a unique situation and kind of special in that, all right? All right. So that is it for today. That's a long day, yes? When we talk law of cosines, it will go much faster, I promise. All right, so on Monday, you have the whole block to work on page 17. And then you can also go back and finish 14 and 12, all right?